Have you ever just looked up at the night sky and wondered something that feels super simple, but at the same time kind of profound? I mean, with billions and billions of stars out there, why is space just so dark? Okay, let's get into it.
So here's the paradox that just doesn't seem to add up, right? We've got one star, our sun, and it's so powerful it makes our entire world brilliantly bright. But then you look out into the cosmos, which is filled with billions of other stars, many way bigger than our own, and all you see is this deep, profound blackness. So what's the deal?
All right, the first part of the answer has to do with something that's hard to wrap your head around. Sheer, unimaginable scale. We have to stop thinking of the universe as a static box and start thinking of it like a room that is just constantly getting bigger.
Imagine this. You've got a small room, and there's one really bright lamp right in the middle. The whole room is lit up, no problem. But now, what if that room suddenly expanded, like 100 times bigger in every direction? While the lamp is still there, it's still burning just as brightly, but now its light seems faint. It's diluted, and it just can't reach those new walls way out in the distance. The space just got too big for the light to fill.
And that is exactly what's happening in our universe. It isn't a fixed space. It's always expanding. This means all those distant stars and galaxies are constantly moving away from us and from each other, getting farther and farther apart every single second.
And this whole expansion thing, it's been going on since the very beginning. We're talking about 13.8 billion years. Over that incredible amount of time, the distances have become so huge that the light from those faraway stars gets stretched incredibly thin. It just weakens so much before it ever has a chance to get to us.
But the size of the room, that's just part of the story. Let's move on to the second reason, which is all about what space is, or maybe more accurately, what it isn't. Think about it like this. If you're in a dark room and you shine a flashlight at a wall, the light bounces off that wall, right? It scatters and lights up the whole area. You see the light because it has something to hit. But what if you pointed that same flashlight into an endless, empty void? The beam would just travel forever. It would never hit anything to reflect off of, and the space around you would stay dark. And that's the crucial thing here. Space is that void. It is mostly a vast, empty vacuum. Starlight shoots out from its source, but there's almost nothing for it to hit. No walls, no atmosphere, barely any particles to scatter it. So it just keeps on going. And without reflection, you don't get illumination.
So we've got an expanding universe and an empty vacuum. That seems to explain it all, doesn't it? Well, not quite. Now we get to the most interesting part of this whole thing, where the answer isn't just out there in space, but right here with us.
We've been looking at the properties of the universe for the answer. But what if the reason we see darkness is because of the very tool we're using to look? What if the limitation is actually our own biology?
To really get this, let's imagine a friend, we'll call him Shamshun, who can see infrared light. If you ask Shamshun if space is dark, he'd be totally confused. He'd say, "What are you talking about? Dark. Space is glowing everywhere." He would see a universe that isn't dark at all, but is actually filled with light.
How is that possible? Well, it all comes down to a really cool scientific idea called redshift. Remember how the universe is expanding and galaxies are speeding away from us? Well, as they race away, the light waves they're emitting get physically stretched out. It's kind of like how the sound of an ambulance siren gets lower as it drives away from you. This stretching pushes the visible light towards longer wavelengths, and for the most distant things, it pushes it right past what we can see, into the infrared part of the spectrum.
And that's the final piece of this cosmic puzzle. Our human eyes can only see a teeny tiny sliver of all the light out there, the part we call visible light. All that redshifted light from faraway galaxies, it's completely invisible to us. So to our eyes, space looks dark. But if we could see an infrared, like our friend Shamshun, the universe would be blazing with this ancient, stretched-out light. The light is there. We're just not built to see it. So, let's put all of this together. The darkness of space isn't a simple question with just one answer. It's really this incredible combination of several cosmic facts all working together. So to recap the four big reasons. First, the universe is huge and it's constantly expanding, which waters down the starlight. Second, space is an empty vacuum, so there's nothing for light to bounce off of. Third, the light from the most distant stuff gets redshifted until it's invisible to us. And finally, number 4, our own eyes can only see a tiny fraction of all the light that's actually out there in the first place. When you really think about it that way, The darkness isn't an absence or some kind of flaw. It's actually a fundamental feature of our universe. You know, it's like the perfect, deep black canvas that provides the contrast we need to see the incredible beauty of every single star, planet, and galaxy. Without it, everything would just be lost in a constant, overwhelming glare.
So that leaves us with one last thought to chew on. If the darkness is what allows us to see all the light and wonder that exists, could it be that the dark is actually the most beautiful and essential thing about our entire universe?